So students, so far in this chapter, phase equilibrium chapter, we have discussed the various statements and meaning of the various terms involved in this chapter, like phase, component and degrees of freedom. What is the meaning of phase, component and degrees of freedom, as well as the statements of these, or I would say definitions of these terms, we have already discussed in detail in the previous few lectures. So as well as we have also discussed an example of one component system, as well as the phase diagram of water system. Water system is an example of one component system. Already we have discussed this portion in detail, so I don't want to spend much time on explaining this concept again. So let us proceed further, and today we are going to discuss the phase equilibrium of two component system, or phase diagram of two component system. Now the examples of two component system already we have discussed while defining the term component. What is the component? Okay. For example, as far as your syllabus is concerned, they have mentioned only the phase diagram of lead silver system, as the lead silver system is an example of two component system. Like we have discussed water system in detail, the different areas, different curves and different eutectic points, as we have discussed in the water system, in the same way we are going to discuss all the terms which we are going to use in this phase diagram of two component system. First of all, let me tell you that today we are going to discuss phase diagram of lead silver system. Lead is represented by a symbol PB. Okay, lead is represented by a symbol PB, and silver is represented by the symbol AG. Okay, PBAG system, that is lead silver system. Now this two component system is also called as solid liquid equilibria. Such kind of phase equilibrium of two component system is also known as solid liquid equilibria, because vapor phase in such system does not exist. Okay, one of the phase, that is vapor phase is not observed in two component systems. That is why it is also said to be a solid liquid equilibrium, because as we know that in water system all the three phases, that is solid ice, liquid water, gas vapor, water vapors, all the three phases where exist. But in all the examples of two component system, they do not have the vapor phase. Vapor phase does not exist, or we can say it exists to the very small extent. So ultimately we can say vapor phase does not exist in two component systems. That is lead silver system is an example of two component system. Now, as we know that water system or one component system has only one kind of equilibrium stage. Okay, either solid liquid, liquid vapor, or solid vapor, or all the three can exist in. But in case of solid liquid equilibria or two component system, there are three different types of two component systems. Okay, three different types of two component system which involves the solid liquid equilibria. The very first type of solid liquid equilibria in two component system. Two component system means there must be two independent chemical constituents mixed together. Okay, like silver lead system involves silver phase and lead phase. Okay, these are the two different chemical constituents, lead and silver, and the composition of each phase can be represented separately by silver and lead respectively. Okay, silver phase is represented by the using the chemical constituent Ag. Lead phase is represented by the chemical constituent PB. Therefore, it is
P.
an example of lead two component system. And broadly we can say that there are three types of two component system involving solid liquid equilibria. What three type of solid liquid equilibria? Okay, we are mixing two components, one is lead, one is another is silver. When we mix these two substances or two components together, there they may be react with each other, they may react with each other or may not react with each other depending upon this fact. Okay, when the two separate compounds in pure form mix together, they may react with each other or they may not react with each other, as well as they may be miscible or they may not be miscible. Miscible means what? They mix together. Like when we mix water and sugar together, sugar is miscible in water, it forms a homogeneous mixture. Such systems are called, such substances are said to be miscible in nature, miscible. Okay, lead and silver system is also uh, miscible in each other in the molten state. When lead in the molten state म्हणजे वितळलेल्या अवस्थेत, when lead is mixed with the silver in their molten forms, they form a miscible mixture or they form a homogeneous mixture. Depending on these two facts, always remember, depending on these two facts. Which are these two facts? One is whether they are miscible or immiscible. The second is if they are miscible, if they are miscible, they may react with each other to form another new compound, or they may not react with each other and to form uh, obviously they, if they do not mix with they do not react with each other, then no problem of forming new compound. Okay, depending upon these two factors, there are three types of solid liquid equilibria. टू कंपोनंट सिस्टीमचं एक एक्झाम्पल आहे लेड सिल्वर सिस्टीम. त्या लेड सिल्वर सिस्टीम ही टू कंपोनंट सिस्टीमचं एक्झाम्पल आहे आणि ह्या टू कंपोनंट सिस्टीमलाच सॉलिड लिक्विड इक्विलिब्रिया देखील म्हटलं जातं. व्हाय? बिकॉज third phase, that is vapor phase, generally do not exist in such kind of systems, in such kind of two component system. Therefore it is also known as solid liquid equilibria. Now there are, I am explaining that there are three types of solid liquid equilibria. Now these three types are categorized depending upon the fact that whether these substances are react with each other to form another compound. Okay, to form another compound. Depending upon this factor, this fact, they are of three types. Number one type is the solid liquid equilibria in which the two components do not react. This is very important. Okay, the two components which do not react with each other, but when they are mixed together in their molten state, they form a homogeneous mixture, means they are miscible with each other. म्हणजे काय, जेव्हा सॉलिड अशा पद्धतीच्या पहिला टाइप काय आहे की ज्यामध्ये दोन कंपोनंट मिक्स केले असतात, ते एकमेकांसोबत रिॲक्ट होऊन तिसरा कंपाऊंड तयार करत नाहीत. समजलं एक पॉइंट. दुसरा पॉइंट काय आहे, ते एकमेकांसोबत रिॲक्ट होत नसले तरीही दे आर मिक्सिबल टू ईच अदर. दे मिक्स टुगेदर अँड फॉर्म अ molten state or homogeneous, we would say homogeneous state. Okay, number one type is understood. कोणत्या प्रकारचा आहे, दोन, when the two components are mixed together, they do not react with each other and form a new compound. जर ते एकमेकांसोबत रिॲक्टच होत नसतील तर नवीन प्रॉडक्ट तयार होण्याचा, तिसरा प्रॉडक्ट तयार होण्याचा काही संबंध नाही. Okay, they do not react with each other, and no formation of third product. But हे जरी असलं तरीही they mix together to form a in their molten forms to form a new substance, to form a homogeneous system. This is the one kind of, they do not react with each other, but they mix together to form a homogeneous mixture. And the examples of such first type is lead silver system and potassium iodide and water system. Okay, the examples of first type they have not named these three types, but they have categorized only three types of solid liquid equilibria. First type, in which two components do not react, but they form a homogeneous mixture. They mix together in their molten state. And examples are, just remember, lead silver system as well as potassium iodide water system. These are the two examples of type first solid liquid equilibria. While moving to the second type, in this type, in which the two components reacts to each other chemically, they react with each other and they form a new compound, third compound. Okay, initially before mixing them together, they have two components, independent two components. Okay, but as soon as they mix together in their molten form, they react chemically with each other to form a third compound. For example, A is one component, B is another pure independent component. When these two A and B in their molten form, म्हणजे त्यांना वितळलेल्या अवस्थेत दोन्ही कंपाऊंडच्या त्यांच्या त्यांच्या वितळलेल्या अवस्थेत जर मिक्स केलं तर ते मिक्स होतात. त्याचबरोबर they reacts with each other to form the third compound, per se AB. Okay, when A mixed with B, they react with each other and form AB compound, AB new compound. Okay, A, B and AB. Now in such cases there are three types of compounds are present in the system. Okay, initially before mixing A, B, when they mix together they react with each other and form a new compound which with the congruent melting point. Okay, काय होतं की जेव्हा दोन वेगवेगळे कंपोनंट मिक्स केलं जातात ते एकमेकांसोबत रिॲक्ट होऊन तिसरा एक सबस्टन्स तयार होतो. त्या सबस्टन्सचा congruent melting point असतो. आता congruent, what is mean by congruent melting point, I will explain it first of all. Okay, congruent melting point of the newly formed substance is the melting point. Up to its melting point that substance remains stable. म्हणजे काय की तो पदार्थ तयार झाल्यानंतर तिसरा पदार्थ AB तयार झाल्यानंतर त्या AB ला काय असतो, एक कॉन्ग्रुएंट मेल्टिंग पॉइंट असतो. तो कॉन्ग्रुएंट मेल्टिंग पॉइंट म्हणजे काय, त्या तिसऱ्या सबस्टन्सला आपण हीट देऊन त्याचं टेम्परेचर हळूहळू त्याच्या मेल्टिंग पॉइंट पर्यंत सॉलिड सबस्टन्स तयार झाला, तिसरा सॉलिड सबस्टन्स तयार झाला. मग त्या सॉलिड सबस्टन्सला आपण हीट देत गेलो, त्याच्या कुठपर्यंत हीट देत गेलो, त्या सॉलिड नवीन तयार झालेल्या सॉलिड सबस्टन्सच्या मेल्टिंग पॉइंट पर्यंत हीट जर देत गेलो तरी देखील तो कंपाऊंड स्टेबल असतो. what does it means? The system in which two components reacts to form a new compound with stable, which is stable up to its melting point. म्हणजे आपण हीट देत गेलो तर एकदा तो कंपाऊंड तयार झाला आणि परत आपण हीट देत गेलो, हीट देत गेल्यानंतर त्याचं टेम्परेचर वाढत जाईल. एक असं टेम्परेचर येईल जिथं तो सॉलिड नवीन तयार झालेला सॉलिड काय होईल, मेल्ट होईल आणि त्या मेल्टिंग पॉइंट पर्यंत तो काय असतो, त्या सिस्टीम मध्ये स्टेबल एक्झिस्ट करतो. त्या अशा सबस्टन्सला काय म्हणतात, द सबस्टन्सेस विथ कॉन्ग्रुएंट मेल्टिंग पॉइंट. I hope it is clear. If it is not clear, I will try to tell you in simple words. Okay, when A reacts with B, form AB, new substance. Okay, this new substance is stable in the reaction mixture until we provide heat to its melting point. तो स्टेबल आहे, लगेच तयार झाला आणि डिकम्पोज, थोडं हीट दिली की डिकम्पोज झाला का नाही, तर तो ॲज इट इज त्या स्टेट पर्यंत राहिला. ओके, कोणत्या स्टेट पर्यंत, जोपर्यंत त्याचं टेम्परेचर, त्याच्या मेल्टिंग पॉइंट, सॉलिड तयार झाला ऑलरेडी. व्हेन टू लिक्विड्स मिक्स टुगेदर they form one new compound which is in solid state. That solid state is stable existence in the system until the melting point of that substance is reached. जोपर्यंत त्याचा तो सॉलिड नवीन तयार झालेल्या सबस्टन्सला मेल्ट होत नाही तोपर्यंत त्याचं एक्झिस्टन्स काय असतं, स्टेबल असतो. तो स्टेबल असतो त्या सिस्टीम मध्ये. एवढंच नाही तर तो सॉलिड सबस्टन्स तयार झालेला असताना त्याच्यामध्ये दोन्ही सबस्टन्सचं काहीतरी प्रमाण असेल. ओके, when the two pure components mix together they form new third solid substance. That third solid substance has a particular composition. For example, A is 20% is present in AB and B is present in 80%. ओके, म्हणजे त्या नवीन तयार झालेल्या ए बी कंपाऊंड मध्ये ए चं प्रमाण किती आहे, 20% असेल, तर बी चं 80% आहे समजा. तर मग कॉन्ग्रुएंट मेल्टिंग पॉइंट म्हणजे काय, एकतर तो स्टेबल एक्झिस्ट राहतो, त्याचबरोबर तो वितळल्यानंतर देखील, ओके, सॉलिड तयार झाला, आपण हीट दिली, तो वितळला, मेल्ट केला, मेल्ट केल्यानंतर देखील त्या मोल्टन फॉर्म मध्ये एचं आणि बीचं सॉलिड मध्ये जेवढं प्रमाण होतं तेवढंच प्रमाण त्या मोल्टन फॉर्म मध्ये देखील असतं. अशा सबस्टन्सेसला आपण काय म्हणतो, कॉन्ग्रुएंट मेल्टिंग पॉइंट. ओके, कॉन्ग्रुएंट मेल्टिंग पॉइंट. आता फॉर एक्झाम्पल एक साधं एक्झाम्पल घेऊन मी एक्सप्लेन करण्याचा प्रयत्न करेन. सपोज इनिशियली ए इज टेकन इन 20 proportionate, B is taken in 80 proportionate, or both they mixed randomly together, but when they mix together they react with each other and form a new substance AB. But while forming the new substance, solid new substance AB, in that AB there is only 20% of A and 80% of B, okay, as a solid. Okay, and every solid has its own melting point. If we provide the heat to that mixture at certain temperature, that solid melts. That solid melts again. But in that molten form also, A remains as a 20% composition and B remains as a 80% composition. Such substances are said to be the compounds with congruent melting point. Okay, congruent melting point. And the example of this system is ferric chloride water system. Ferric chloride water system, the example of second type. Okay, they react with each other. First was they mix together but they do not react. Here they mix together as well as they react with each other and form a compound which has the congruent melting point. That means they mix together, form a solid compound. When solid is melted, their composition remains same as it was in the solid state. As it was in the solid state. Such compounds are said to be compounds with congruent melting point. An example is ferric chloride water system. The third type of compound is, that is third type of solid liquid equilibria is in which the components reacts to form a compound with incongruent melting point. Just remember, second was they reacts with each other, form a compound with congruent melting point. म्हणजे काय congruent melting point म्हणजे काय, की तो थर्ड सबस्टन्स, सॉलिड सबस्टन्स तयार झाला, त्याला मेल्ट केला असता, सॉलिड मध्ये जे कंपोनंटचं प्रोपोर्शन होतं, कंपोजिशन होतं, तेच त्याच्या मोल्टन फॉर्म मध्ये किंवा लिक्विड फॉर्म मध्ये देखील तेच कंपोजिशन मेंटेन झालेलं असतं. पण इथं काय होतं, आणि दुसरी गोष्ट काय होती, इथं ते कंपोजिशन तर मेंटेन झालेलंच आहे, पण त्या मेल्टिंग पॉइंट पोहोचण्यापर्यंत, त्या तापमानापर्यंत तो सबस्टन्स स्टेबल ॲज इट इज सॉलिड राहतो. जेव्हा तो मोल्ट होतो, त्या टेम्परेचरला रीच होतो, त्याच्या मेल्टिंग पॉइंट पर्यंत, तेव्हाच त्याचं काय होतं, मेल्टिंग स्टार्ट होतं. पण थर्ड टाइप मध्ये काय आहे, व्हॉट इज इन द थर्ड टाइप In third type, they mix together, they react with each other, they form the compound, but the formed compound is not stable up to its melting point. म्हणजे तो एकदा तयार होतो, पण थोडीशी जरी त्याला हीट दिली तर परत तो डिकम्पोज होतो. त्याच्या मेल्टिंग पॉइंट पर्यंत स्टेबल राहतो का? नाही. ओके, जो की दुसऱ्या टाइप मध्ये होता, तो नवीन सबस्टन्सही तयार करतो आणि त्याला हीट दिल्यानंतर पार तो वितळेपर्यंत तो त्या एक सिस्टीम मध्ये स्टेबल राहतो. पण इन केस ऑफ थर्ड टाइप, as soon as the two substances mix together, they form a third substance, but that third substance is not stable up to its melting point. Even if slightly at a higher temperature, the newly formed substance undergoes decomposition. Okay, undergoes decomposition. That means it does not remain stable up to its melting point. Up to its melting point. On heating, it starts decomposing before the melting point to give a new solid phase and the solution with composition different from that of okay. Second मध्ये काय होतं प्रमाण? It forms, it melts, but up to its melting that has the stable existence. But in third step, they form, they react with each other, they form the third substance. On heating, the substance undergoes decomposition and forms the न्यू काय होतं, एक सॉलिड स्टेट होते आणि एक मोल्टन स्टेट तयार होते. त्याला म्हणायचं आपण कंपाऊंड्स विथ इनकॉन्ग्रुएंट मेल्टिंग पॉइंट. दुसऱ्या टाइप मध्ये पहिल्यांदा वितळलेल्या अवस्थेत सिल्वर आहे, लेड आहे, त्यांच्यापासून लेड सिल्वर सॉलिड तयार झाला, त्याच्या मेल्टिंग पॉइंट पर्यंत तो सॉलिड स्टेट एक्झिस्ट राहिली. पण थर्ड टाइप मध्ये ते मेल्टिंग पॉइंटला पोहोचण्याआधीच तो काय होतो, डिकम्पोज होतो आणि एक नवीन फेज तयार करतो. Such type of compounds are said to be compounds with incongruent melting point. They do not remain stable until they reach to its melting point. Such substances or compounds are called compounds with incongruent melting point. Okay. Now the example of such type is sodium bisulfate water system, Na2SO4 H2O system. Okay, the first type's example is lead silver system, second is ferric chloride water system, third is sodium bisulfate water system. Now let us see the phase diagram of lead silver system. Now this is, as far as your examination is concerned, this part or this portion is I would say it is important. If the examination is going to be conducted offline, then this question may be asked. Explain the lead silver system, or the same question can be asked in other words. Explain the phase diagram of two component system. If the question is asked like this, then you have to explain the lead silver system. Okay, phase diagram of lead silver system. Now again students, only 6 minutes are left to end this meeting, so I request all of you to join the class again by clicking on the same link which I have sent to WhatsApp group. Okay, I request once again, those who have not listened, I request all of you, please, after 5 minutes the meeting is going to be ended, so I request all of you to rejoin the class by clicking on the same link, and probably I would take more 10 to 15 minutes only. Okay, now lead silver system is an example of, now while explaining these three, the same pattern you need to explain this system as we have explained in case of water system. Okay, the way we have explained the water system, in the same way we have to explain, you have to explain the lead silver system. Okay, this first line must, you should be the lead silver system. Lead silver system is an example of two component system. Why? Because whatever the phases of lead silver system exists, the composition of all the phases can be expressed with the help of two independent chemical constituents, and these two independent chemical constituents are Pb and Ag. Okay, at least we require two independent chemical constituents. Now, before dealing with the lead silver system in detail, let me tell you this lead silver system consists of four phases. Okay, sorry, three phases. Okay, one is pure lead, another is pure silver, and third is molten form of, okay, solution of lead अँड सिल्वर. म्हणजे लेड सिल्वर सिस्टीम मध्ये एकूण किती फेजेस आहेत? थ्री फेजेस. ओके, विच आर दे? सॉलिड लेड, सॉलिड सिल्वर, अँड लिक्विड silver and lead. These are the three phases exist in lead silver system. Just remember, number of phases are three. Now, to explain the composition of all the three phases, we require at least two chemical constituents, and these two chemical constituents are lead and silver. Therefore, this lead silver system is an example of two component system. I hope it is clear to you. Number of phases are three and number of components are two. Now, again, if you look at this phase diagram of lead silver system, you will observe again this phase diagram is can be divided into three parts. This phase diagram can be divided into three parts. This phase diagram consists of different regions, and these different regions are three in number. One is the region above ACB. Okay, this region. Okay, this region ACB. The region above ACB is one area. The another one is region below the curve AC. Region below the curve AC, or I would say the region below the curve ACD. Okay, ACD. This region is one area, and the region below BCD, this one also belongs to the existence of one phase. This area belongs to, okay, initially the phase diagram is divided into three parts: areas, curves, and eutectic point. Number one, area. In this phase diagram, we can observe three different areas, and these three different areas are the area above ACB, the area below ACD, the area below BCD, and three different areas corresponds to the three different phases. Three different phases. The area above ACB belongs to the existence of solution of lead and silver. Lead silver system इथं molten form मध्ये, वितळलेल्या अवस्थेमध्ये हे सोल्युशन इथं आढळतं आपल्या कुठल्या कर्व ACB च्या वर. And below the area ACD, you will observe only one solid lead system. Only one phase is exist, solid lead. And below the area BCD, there exists only solid silver. Okay, above ACB, solution of lead and silver. Below ACD, only solid lead. Below BCD, only silver, solid silver exists. Okay, now this is all about the explanation of these three curves. Within 2 to 3 lines you have to explain the areas. Okay, region above ACB, by only, if you remember this slide only, you can easily write